Welcome and thank you for joining us today. This Hydrotest related webinar is an overview of pressure test planning. As always, our goal at Technical Toolboxes is to provide thought leadership and cultivate professional growth. Today's speaker will review some of the issues facing companies and engineers that conduct pressure tests. Additionally, we will tell you about Hydrotest tools from Technical Toolboxes and the resources we provide to help you advance your career. Next slide, Norlin. All pipeline documentation must now be traceable, verifiable, and complete. New pipelines must be verified and existing assets recertified. Hydrotesting is an exceptionally effective method to meet those challenges and others, such as diagnostic tool and pinpoint defects caused by accidents. Pressure testing comes with its own set of considerations for operators and communities in which tests take place. These include operational and environmental safety and how to source and dispose large quantities of water used in a test. We will be highlighting how the Hydrotest PowerTool from Technical Toolboxes is a viable engineering solution for pressure test planning that addresses these concerns. Next slide, please. Before we introduce our speaker, please join us in taking a quick poll. Our speaker today is Robert Barbold. He's a principal engineer at DNV-GL in Columbus, Ohio. Before joining DNV, Mr. Barbold rose through Colonial Pipeline's ranks to ultimately serve as VP of Technical Services. He holds a Bachelor of Science in Mechanical Engineering from Georgia Tech. During his career, Mr. Barbold has planned, conducted, and evaluated numerous hydrostatic pressure pipeline tests. He's also played a key role in evaluating and documenting all existing test records for all Colonial's pipelines for MLP validation. Since joining DNV-GL, he's participated in integrity management plan updates for liquid and gas pipeline operators and assisted in regulatory reviews of pipeline and facility conversion projects. He also serves as an operational and technical advisor to DNV-GL's litigation support team. So I now turn the floor over to Mr. Robert Barbold.
Thank you. Next slide. Okay, so what we're going to talk about today is pressure test planning. And I'm emphasizing planning. And also note, I talk about pressure test and not just hydrotest. Because testing in gas, whether it be air, even natural gas, or nitrogen, is an acceptable practice with certain precautions and other requirements. But all this goes to planning for the test. Next slide, please. Now, a driver for the increase in need of pressure testing are the changes we alluded to in regulations, primarily in 49 CFR Part 192, otherwise for pipelines that transport gas, the so-called mega rule. In the mega rule instituted some requirements that require operators to potentially certify their maximum allowable operating pressures, their MAOPs, on their transmission lines. And I just as an aside, I like this particular picture here because it emphasizes some things that I talk about in my class. If you note the individual in the background there, what appears to be an individual playing golf, do you think he has any idea what's going on in the foreground as he's about to hit that shot? The answer could be probably no. Do you see the the person in the nearest us is probably a testing personnel. You see where he is located in relation to what we're assuming is the piping under pressure, and you have to take considerations like this into account when you're planning a pressure test. For instance, The gentleman that's golfing appears to be in the middle of the fairway. If I was out there, I might be actually closer to that fence or in that tall grass looking for a ball. So, you know, as a person who does a lot of pressure tests told me, a contractor, one of the most important things you need to know while doing a pressure test is distance is your friend. Okay, and so the people don't need or to be close to what's under pressure, and you got to protect the public as well from potentially being in the wrong place at the wrong time. So this all goes into when you're planning a test. Next slide, please. Now, why the need for certifying existing MLPs? Well, if the records aren't, as we talked about, traceable, verifiable, and complete, then recertification of an existing MAOP on a pipeline may be required. One method of doing that is by doing a pressure test. Now, I've worked with a client where they went over their historic record and it was traceable, verifiable, but was not complete. It may have technically met the requirements of the 192 code, but in this particular case, the record that was being reviewed did not describe the test section. So if you put yourself, if you put yourself in the regulator's kind of shoes there, how do you know what exactly was tested in that particular test? Was the entire segment tested? Was a portion tested? So in that case, it was traceable, verifiable, but it was just not complete, and thus did not pass muster, and would need to be tested again as part of an integrity assessment at a near future date. And what I mean by the last point there is, you may actually, if you look at the requirements in particularly in 192.517, you will see that the records must at least contain list does not actually require a description of the segment being tested. However, I will tell you, it is a very good idea to have the description of the test section done. And such. So in my class, we've got to go through the regulations and understanding what is needed to actually meet the requirements. Next slide, please. Now, one of the significant parts of the changes to 192 was the removal of the so-called grandfather MLP limits, which were based on operating history and such. So if a pipeline operator wants to keep their current MLP and they don't have the records to justify it, they may have to do a pressure test, or one method is a pressure test, meeting the subpart J requirements on the line. Other actions are available to the operator, including reducing the limit or the MLP on the line, using actually operating pressures, and there's other options also available. However, to keep the current MLP, testing is an effective method for reconfirming that limit. Next slide, please. And there's other reasons for doing pressure testing on pipelines. Integrity assessments. Pressure testing is a common tool used in industry to determine that the integrity of the segment or system is sound, and it's used for that. But you might set different requirements for doing an integrity assessment as you might do for recertifying an MLP. So depending upon what you're trying to do sets what you want to plan for when you start planning for a pressure test. A spike testing, if that is required for a particular thread on your system during an integrity assessment and such, you need to plan for that also. when you might be going to higher pressures than you might do in other types of tests. So again, starting off with what are you trying to do so that you can understand what kind of requirements you want to put into your plan for the test. Next slide, please. Other reasons, obviously we talked about reconfirming the MLP, but another reason testing may be done on a line is tightness testing, or what I maybe call just a leak test. And these may be required by local jurisdictional authorities to do annual tightness testing or leak testing of a line, but they also may be done for another reason. I've seen in my career, there might be a tightness test done to resolve a local finger pointing game, so to speak. But the conditions of a tightness test are, again, very different potentially than you might do for an integrity assessment or a recertification test. I've seen in my career where, hey, we're going to do a tightness test, a leak test to verify something. And they actually did in this case, a subpart E test, and actually essentially reset the MLP of the line without really realizing it. And they didn't do it at a pressure they really should have done it. And so there's understanding of what you're doing again, and to avoid having hard discussions about whether that was the intent of the test or not. But you've done actually a regulatory test now, and essentially may have to use it now for your MLP. The secret there is to avoid the argument at the beginning by not making a tightness test or leak test if it's not required, a regulatory test. So these are also things discussed. Next slide, please. So key is understanding why you're doing the test so you know how to plan for the test. For example, new construction. It's another test, a reason for a test. And what you're doing it for is, okay, establishing an MLP, but also you want to think about, I'm also trying to ensure the quality of the materials I have, the construction, the installation, the fabrication, okay? And in my experience, I hate to have a pressure test set a limit on a system. I like for the materials and the construction methodology to set those limits. In other words, I want to get everything that I pay for when you're going to build something new, and it's setting those requirements in advance is, to me, very important, because I don't know if you all been involved in construction activities and such, but it gets all too easy when you get towards the end of a job to rationalize, well, we really don't need to test it to that high pressure. We don't really need to do that. All it needs for operations is this, and then next thing you know, you don't achieve the maximum potential of what you just built, and you never know. I've seen it where, okay, 10 years down the road, 15 years down the road, conditions have changed, and now you want to use it that way. Now here you go, you're limited by a pressure test instead of what you could have achieved had you done the test properly in the beginning. So that all goes into planning. And again, understand why the test is being done, what you're trying to accomplish, and such, and ensuring that's completed. Next slide, please. Now, it's probably one of the most important part of doing a pressure test is the documentation, and it's a pet peeve area of mine. These days, nothing really can be considered done if it's not properly documented. And in my experience, folks tend to like the so shall it be said part and so shall it be done parts of a project, and not so much the so shall it be written part. So yeah, generally it can be regulated to maybe more junior or less experienced folks, and that can really be a costly mistake later on. Proper planning determines the documentation you need. at the end, and also kind of the quality of the documentation you're going to need at the end of the test. You know, for a tightness test that's just done for intercompany use or something like that is going to be quite different than a test done to establish an MLP for a regulatory body, and it needs to be, you know, different and such. So again, documentation, starting off understanding the documentation you're going to need or want is very important in planning for a Hydrotest. Next slide, please. And there's a better way, I should say, than to learn the importance of good documentation than having to review, you can't use the word old these days, dated records, okay? As I did do an extensive review of some dated records in my career, and you really don't want to put yourself in the place where, unfortunately, you try to decide who was drinking more back then, the people doing the test documentation or the survey crew doing the as-built, because things aren't matching, and you're trying to make sense of this data, trying to figure out exactly where these folks were, where their pressure, you know, point was coming from, and what was actually in the segment being tested. It's the record really, and this is one thing I emphasize in my class, the record has to stand on its own. So some of the things that you can be facing is you've acquired new pipelines or new systems and such. Original records are lost. You can never count on the people who've done the test to actually be around, okay, to help you understand it. Historical records may not be, you know, traceable, verifiable, complete. I've seen records that composed an entire hydrostatic test record was a 3x5 piece of paper, okay? And typically they're all on paper, you know, and that can be a challenge for folks these days, is that not everything is available on a Google search or an intercompany search and such. It's on paper, research is manual, and that research requires people with experience and knowledge in what they're seeing and how to go through records and looking for things to help verify that the test was done. You know, records that are required to traceable for the components and materials used, and getting all that together so that it's a complete record. And this, again, you know, it's not a task really for new or minimally experienced personnel. It usually takes an experienced person to put some of these historical records together. So what I emphasize is, when you're planning your test, is planning for that documentation and ensuring that you have everything you have at the end of it. And like I said, the record has to stand on its own. It has to tell that complete story. And nowadays, sketches, drawings, pictures, all are tools that should be used as part of records. A drawing doesn't do it by itself, but it really helps the people understand what was being done or what was tested. Pictures can really describe the testing apparatus. It can also show you what was being under test and such. All these things now, the tools we have, really is no excuse to have incomplete records. And yet I still see recent Hydrotests where you're struggling to put all the pieces together, just because the folks that were doing it just don't have that knowledge or competence, and they didn't have a really good plan and requirements to what they needed at the end of the test. Next slide, please. So this is generally the outline of my 3-hour class that I give. It's really designed to provide a foundation to how to prepare for planning for a pressure test. In addition, I give some personal experience and opinions, okay, and what to look for and how to ensure you have a good pressure test. And you know, what constitutes a good pressure test, and how do you know, and where people should be probably during the actual test. extending a test an extra hour or two to see a trend that cannot be basically defined or described by a leak can save you so much headache and pain than by thinking you're saving time by ending the test right at the end of the prescribed time that you wanted it. Extending it just an hour or two to see a good trend line answers so much questions or so many questions later on. And so to me, as I like to have folks that are competent, understanding what they're looking for, both from an operator point of view and from a testing contractor point of view, they're at the test, making those decisions, and not just, okay, here's the test records, tell me if it's good or bad. So again, my personal opinion. And I also like to emphasize decisions the operator may need to consider for the safety. We talked about that at the beginning. Safety of the public during the test. If you're testing inside your facility, it's one thing. If you're testing a pipeline along a right of way through neighborhoods and such, it's a big part of the planning effort. Is how do you ensure the safety of the public as well as the testing personnel during that pressure test. And finally, one aspect that may be overlooked in some pressure testing, and this talking to some testing contractors, is planning for failure. And it's something that you don't want to happen, and but if it does, and when it does, you need to be prepared for what actions you're going to take, and different types of failures. You have a slow leak failure, you have a rupture failure. What are you going to do, and how are you going to address it? What do you want the contractor to be doing during the slow leak? Do you want them to keep pumping? Do you want them to shut down? Do you want to start draining? In a rupture, okay, those tend to find themselves, make it much easier. But in a slow leak, you might want the contractor to keep pumping, so it's helpful to try to find those. Bottom line is, you don't want to be making up that plan when it happens. You want to be able to fall back on a plan you already thought about in light of day, calm. You want to be able to have the resources that you need available, either on standby or there if it's going to happen, all depending on what you're testing and how important it is that if it's a critical part of infrastructure, you may want to have much more robust planning. If it's not that critical and downtime is wide, available, that's a different part of your planning. But the main focus is to have that plan in place ahead of time. And then one of the things I like to cover at the end there is some expectations that a testing contractor will have for the operator. What needs to be known and clear, but for the testing contractor and their expectations for the operator, and of course, obviously vice versa, what the operator is expecting from the testing contractor, and making sure that is clear ahead of time. And then finally, I'll talk just a little bit test sectioning and pressure determination. The tool, I think, that the technical toolboxes has can help you if you're doing a long line with a lot of elevation changes and such, can help you plan for sectioning and making some pressure determinations, which you can weigh against cost and time. But you have to be able to be a little flexible with your pressure limits and understanding what that's going to mean for you in the future as an operator in setting the MLP. And then the regulations I talk about is there are differences between the 195 and 192, and understanding those differences and how you need to plan for that. and such. So that's what we kind of cover in a real high level kind of synopsis of my pressure test planning seminar. It says 3-hour class. Okay, well, I'm going to turn it back over. Concludes my portion.
Thank you, Robert. Appreciate it. It looked like there were several folks that came onto the webinar a little bit later, so just wanted to maybe reintroduce. That was Robert Barbold, who is a subject matter expert from DNVGL. My name is Paul Schumann, and I am a product line manager here at Technical Toolboxes. And maybe just want to recalibrate here. We're about halfway through our time. Robert went through kind of some of the current issues that companies are facing. In the time that we have left, we're just going to take a quick peek at some of the tools that Technical Toolboxes offers that can possibly help you guys in facing these issues within your existing company. So looking forwards, you guys face many challenges in today's environment. Coal and energy is a main source that oil and gas is still trying to overtake. The U.S. Energy Information Administration projects that economic growth will continue to drive the U.S. gas consumption and exports. The mega rule, combined with market conditions, mergers, acquisitions, is driving operators to take a fresh look at records in the pipeline for assets. In anticipation of the need for more efficient Hydrotest planning methodologies, Technical Toolboxes has developed the Hydrotest PowerTool. Next slide, Norland. The Pipeline Hub from Technical Toolboxes is an integrated data environment for pipeline engineers. The hub gives your engineers more time to contribute more value and pursue new business opportunities for your company. It makes all of your data available for analysis all of the time and stores your output for future use and other workflows. It frees you from repetitive data management tasks and eliminates the error and inefficiencies of manual data entry. Given the call for more pressure testing, the Hydrotest PowerTool is a welcome addition to the integrated desktop and cloud-based resources and specialized training that Technical Toolboxes has been offering for more than 2 decades. And next slide. The hub includes more than 250 engineering technical tools and calculations. Technical Toolboxes is also an authorized PRCI software reseller, which gives you additional access to a range of industry software tools. We provide live training events for professional development hours. Currently, these are all online due to the pandemic. You can visit the training section of our website at technicaltoolboxes.com for a full listing of upcoming classes. Next slide. The PowerTool reduces the amount of investigative trench work to increase ROI on both software investment and pipeline infrastructure and saves time. Additionally, because it stores your data to the hub for your future reference, your investments in calculation and analysis are preserved. In summary, the Hydrotest PowerTool provides a semi-automated and intuitive process to create complex Hydrotest plans to ensure compliance with CFRs 192 and 195 for both new and existing pipelines. And next slide. The latest generation of software tools from Technical Toolboxes built on the Pipeline Hub integrated data environment. Technical Toolboxes has developed a range of power tools designed to maximize pipeline engineering productivity. The company is a thought leader and knowledge resource provider with live and online training for PDH credits for pipeline engineers. So now we'll just get into the next slide. Just a brief overview of the training services. So on our training website, which is on technicaltoolboxes.com, you can go online and find courses for pressure testing, design and safety for basically all aspects of the pipeline life cycle, whether it's design, operations integrity, and MLP confirmations, you name it. So the for next class that Robert has planned is for June 23rd for Hydrotest planning. And then we are planning for everyone on this call today to do a Hydrotest PowerTool software demonstration to show kind of the planning tool that we've just recently developed and deployed on our hub environment. So we're going to plan to have that on April 27th. So there will be an email reminder that'll be sent out after this, and if you're interested in attending that, just reply, and we'll be sure to include you on the invite. So before we get to the Q&A session, let's join us in taking another brief poll. So it looks like the majority is performing validations or recertifications, followed by, we have trusted contractors, and then another 21% or so says other, just to provide a little feedback there. All right, so what's the most meaningful next step for you? You can stick around for a Q&A session that we're going to have following here, and ask any questions that you would like of Robert and or technical toolboxes relative to products and services. As noted previously, we'll be sending out the registration for the email for those interested in a software demo. And with that, I'd love to hear any feedback that you have with respect to the webinar, and you can just post that in the chat window. And any questions to be posted, please post that in the chat window as well. And then I'd like to introduce Joseph Ladner, who is our main engineering performance advisor here at Technical Toolboxes, and he will be leading the question and answer discussion.
Appreciate that, Paul. Good afternoon, or maybe even still morning for some of you, wherever that may be. As Paul stated, my name is Joseph Ladner. I'm an engineering performance advisor here at Technical Toolboxes. So what we're going to do, ladies and gentlemen, is spend the next roughly 20 minutes going over a Q&A session with questions for either Technical Toolboxes or questions for, you know, really for our SME today, Mr. Rob Barbold. And what I'm going to start off with is I see a slurry of questions coming in now. We're going to try to cover as much as we can, but I see some that I can kind of lump into, you know, several questions that are pretty similar. So I see some questions is, will this be recorded, and will this be sent out at a later point? So, of course, we are recording this, and we will, like our other webinars that we send out, put it on our YouTube channel at a later point when we're able to get that formatted and ready to go. So just go to our YouTube channel, routinely check that out. You can look at the other webinars we put on there, such as HDD, AC mitigation, hot tapping, you name it, should be on there. I've seen some other questions. I'm just going to reiterate what Paul has already stated. Essentially, you know, how can we get a chance to either trial, see the software in action, such as a demo, or just get more details on the Hydrotest PowerTool application? As Paul stated, April 27th will be the actual software demo. We'll be performing that, and also we'll have an SME there as well to field technical questions. That will be similar format as this, and really want it to be an open forum and for everyone to get an idea of that. And for anyone who registered for this particular webinar will get the blast to that's how that will take place. So if you have a colleague that did not register this and they want to attend, just forward in the invite, and of course they can easily attend. The Hydrotest PowerTool application is a advanced tool compared to what is in Pipeline Toolbox. I do see a couple questions throughout there. You know, what's the difference? Is this the same tool that if you utilize our Pipeline Toolbox software, you're correct. We do have some testing modules in there, but the Hydrotest PowerTool is something completely new. It's been out for a little bit, but it is much newer and much more advanced, much more of a design, planning, and reporting application as opposed to what you have in Pipeline Toolbox. So it's a much more advanced application. But I really want to try to take advantage of the time we have left and get to some of the technical questions that I see that Rob will be able to answer. So Rob, I'm going to start firing off some questions for you, sir, if that's okay for you. I have several queued up and ready to go.
Sure.
And I'll just start firing your way, sir. So first question for you, Rob, if you are doing a spike test, how long would you keep the pressure at this level to meet the intent of the test?
Okay, spike test, what you really, spike test, you're bringing it up the pipe to, if you're doing a full, close to 100% of spice. After the pressure stabilizes at whatever pressure you set for the spike, you really want to hold it just 15 minutes. Really holding it any longer does you really no good. In fact, it could do even damage that you don't want. So I would say 15 minutes after you've reached pressure stabilization at the set pressure for the spike. So 15 minutes.
Okay, perfect. Appreciate that, Rob. Got another question for you, sir. I'm just going to start kind of rattling them off to you.
Okay.
Does the person approving the test from the operating company or from a third party have to be OQ qualified?
Interesting question, because all the people doing the test, actually, putting the pipe on test and such, all have OQ qualifications for that. So what about that person who comes in and says this is good or this is not good or I accept this or not from an operator or third party or such? And actually, no, I find no requirement for that individual to actually have an OQ qualification. Again, you don't want to pick a person off the street to come in and flip a coin. I mean, so you want to have somebody that's obviously well versed and competent in looking at the test and understanding it. But there is no specific OQ that I know of. This has come up in question in my class for the person instance approving the test. I may
Okay.
add a little. Some operators will actually require the individual to PE stamp the test, and that is an individual operator decision to make. Again, that's kind of setting your in your planning what you want to see in your documentation. That is not a requirement, but some folks do like to have a PE stamp on the test to certify. Other folks will let the testing contractor themselves approve the test. The operator may just accept what is given them. So that, again, in the planning, you're kind of setting that up ahead of time so the contractor knows what's expected of them. Are they the ones approving, or is the operator owner of the line approving? Does the contractor have to provide a PE stamp or not, and such? So that should all be clear up ahead of time. But as far as for the question, no OQ really qualified are needed for the approval of the test.
Perfect. Appreciate that. Really do appreciate that, Rob. Gotta have another question for you, sir. What's the technical rationale behind prescribed test hours, whether it be 4, 6, 8, whatever it may be? And a follow-up to that question is, how do we determine max amount of time required for a pressure test? And I can repeat that if need be.
No, I think I got it. It's funny, that question's actually come up also is, above ground 4, below ground 8. Okay, that's a liquid code. Gas code, it's 8. Okay, what makes 8 the magical number rather than 7 or 12? I really can't answer that. The only thing I could fathom is back in the, I don't know, when they first came out with maybe B31.4, B31.8. They all sat around the table and somebody threw out numbers and they settled upon 8 or 4. So I don't know really. I can't really answer what the particular rationale. I know a lot of companies, especially in the 50s and 60s, 24 hours was used. You held the test on for 24 hours. That was before there was a regulatory requirement set, but some companies set 24 hours as a minimum test period. So I hate to say this, but I really don't know of a technical rationale for why it's not 6 or 8. I do know, most codes, 4 hours of an 8-hour test is the strength component. The second 4 hours is a leak component. In the liquid code, you can, take 4 hours, has to be at 1.25, and the second 4 hours can be just at 1.1 of your MAOP. Gas code, it's a little bit all 8 hours. In Canada, it's again much more like the liquid code for the lines there. So I guess a long rambling answer to say I don't know. I don't know the technical rationale for why those hours.
Okay.
Great question.
Appreciate that. Yeah, appreciate that, Rob. Got some really good ones coming in here, sir. So what are protocols that should be considered when encountering a pressure test with a slow leak, in your opinion?
Okay. To me, I always like, you've got a slow leak, and it depends, how, the length of the segment you're testing, okay? In trying to find that slow leak. I like to keep the pipeline. My personal thing is if I'm trying to find a slow leak, I like to keep pumping so that hopefully I can spot this wet spot on the ground or and to help me to locate it. Because obviously walking the line, probing the line, if it's buried, and such, to try to find it. Okay. If you got a real long section, what I've seen done and had to do is and this is great because it kind of goes into failure planning. All right, if I have a long section and I have a failure, where am I going to divide this thing in half and test each side to figure out which side it's on? If I'm testing a 10-mile line and I got a slow leak, that could be just a really difficult task to try to find. So if I plan for kind of failure, I've already had a spot picked out where I'm going to segment this line into 2 5-mile segments and pressure them up, and now I can clear one or the other, hopefully. And now I've reduced my area to search, and may have to keep doing that. So that's, I don't know if that really answers the question, but that's kind of the thinking you need to go into. Now, if I'm in my facility and I'm testing several hundred feet and I got a slow leak, then I just may have to start excavating and or probing the line and looking for it. You can also introduce potentially even, if you're testing in gas, you can put a tracer gas and then walk the line and such and look for that tracer gas. You can also do that. I think in water also is inject the tracer gas and try to detect things that way. It all kind of goes into your planning for failure and how to do it. But I know a slow, people think, oh God, it ruptured, that's terrible. Yeah, but at least you know exactly where it is, and you can get to fixing that and moving forward essentially a little bit quicker than it is for a slow leak. I hope that answers the question. In how and what you would do for a kind of a slow leak.
Okay, perfect. Appreciate that, sir. I'm going to somewhat stay on a similar topic and piggyback off that with how do you differentiate a slow pressure loss caused by entrapped air from a true leak?
Great. Time. Okay. Okay. If you have a slow leak, that it will continue. If you have trapped air, eventually it will be basically entrained in the fluid, and then it will bottom out, so to speak. And this is it's a great question because there always it comes up in the class, how do you know if the test is good or not? Okay. And I'm a big, the big believer in trending. I mean, there's a lot of good tools out there looking at, okay, I know how much air I had. Okay, I know my temperature or best guess at the temperature because I've taken temperature usually at only a few spots. But I can trend things and I can explain this pressure loss with temperature. I can do the math and all that, and it all works out, and I've got a good test. My concern with that is you just have to imagine yourself on a witness stand, because there's other people that can do math too, all right? And they can show different math, all right, to say a leak explains this just as well as your math does. And everybody's now arguing over math and such, and you've got lay people who are going to decide this. I just, you just don't want to put yourself, to me, in that position. So that's why I say kind of time, because if it's just in trained air and it's not a slow leak, that trend line will change. In other words, if you've got that slow downward, it will flatten out. Okay, and that's what you're looking for. You want that line to flatten out and either hold, or even better, oscillate up, oscillate down with the inherent inaccuracies or the tolerances of your measuring equipment. You should see kind of a bouncing up and down. That is not a characteristic of a leak. Okay, you cannot define, say, okay, that's not a leak. Now, of course, if you really want to get into it, well, it could be a crack that's shut. Okay, but you're in a much better place just by extending that time to say, look at what it's doing now. It's either slowly gaining or slowly losing over time, in your whatever 15-minute, 30-minute, hour increments that you're measuring. Again, planning for that and what you're going to do and how you're going to trend it. That cannot be described as a leak. And so I've got my time in. I've got a trend that can't be described as a leak. I've got a good test. Now, what you have to do is also live with that pressure. If you've lost too much pressure, which is always, is why it's good to get rid of the air in the test section before you put it on test and such. Then I have to live with that pressure that I have set for that test. So so hopefully that answers the question, how to differentiate and what you should do. And to me, the quick answer is just let it stay on test a little longer and let that trend line prove that it's not a slow leak.
Awesome, thank you, sir. Gonna throw a question at you that I believe is kind of looking for your professional opinion, but what would you say, Rob, in a few words on the phenomenon of a pressure reversal? Essentially, what is your opinion of that and what is it?
Pressure reversal.
Yes.
A few words. I don't know what that means. Let's see.
Your opinion.
Yeah. I guess what you mean by pressure reversal is that you've lost, suppression, all of a sudden the pressure is starting to rise.
Yep.
And such. And obviously you can explain that with, temperature. Okay. Temperature's going up, your pressure, is starting to rise, especially, above ground test, depending on, like I said, planning, if you put it on test in middle of the night and it gets colder by the, right before dawn, and you're going down and all of a sudden the sun comes up and everything starts going up. Well, it's temperatures, the sun pressure basically, and things are coming up. So I don't know exactly how professional opinion wise is any kind of change in pressure, to me, has to be explainable. Okay. If you got a pressure reversal, then you've got to have something else going on there that's causing that pressure reversal. All right. Whether it be temperature, pretty much got to be almost temperature. Because you can also have, if it gets too cold, water starts to expand. You're going to get up, even though the temperature is dropping, you can get a rise in pressure. I've had that happen to me. The sensing line froze, and so the pressure went way high until you thawed that back out. So I don't know if that really answers the question. To me, I guess my personal opinion is you have to be able to explain it, okay? And the best way to explain things is not to have them, okay? It may be a retest or start over kind of thing. You can start the test over during the test. As I tell people, you can repressure the test section if the pressure gets too low. All you're doing is just resetting the clock. You can drain product off or water off or the test medium off during the test and still have a good test. You just have to measure it and note it and such. So you just have to understand or explain why you have that pressure reversal. Hopefully that answers the question.
Yeah, no, I would appreciate that, Rob. So got another one for you here. I think this is a good one. You'll like this one. So in a hydraulic pressure test, would you recommend allowing the test medium to remain in the pipe for 24 hours or some other period of time prior to the test being conducted to allow the medium to stabilize?
Oh, yes. Oh, yes. Oh, I leave it in as long as you can to stabilize. It just makes the test go so much easier. 24 hours to me is
the longer the better.
Minimum. I like 36 if I can. Especially if you do a new construction and you can fill that pipe or whatever you're testing with water and let it sit. Testing contractors that I talk to love to be able to let that water sit, okay, for a good 24, 36 hours to let it stabilize. Now, yeah, that just helps you so much to get a very stable, straightforward, pressured it up, pressure held, temperature may varied a little bit, pressure held, everything's fine. You got your 8 hours, you go 15 minutes longer, okay, I've got it all good, we're done, okay? So if you can afford that stabilization time, it makes your pressure test go much more smoothly, okay? Now, you still have the phenomenon, and you're gonna have, it's not unusual, okay, I've let it stabilize for 24 or 36 hours, but when, just the very act of pressuring it up is going to raise the temperature a little bit. You're doing some work on that fluid, so it's still pretty natural. Is once you get it to pressure, it drops a few. The pressure drops a little bit as that fluid, cools basically there. But that should stabilize out pretty quickly, not in the first hour or two. And then you're pretty much constant along the way. And that really, depends on the length of the section also. But I am a big proponent of letting that test medium stabilize for at least 24, if not 36 hours prior to testing.
Awesome. I think we can squeeze in one more question here for you. The question is going to be, when going to 90 to 100% SMICE, Rob, do you need to limit the rate of pressurization? After completion of the test, do you need to limit the rate of pressurization?
I'm not so much. When you want to be able to control, okay, so you don't overshoot. All right. So if you're doing your stroke counts and everything, you kind of know how the rate you're going to be pressurizing the segment. I don't know if I don't really have a set, limited to 1 PSI over every 10 minutes or any kind of, guideline for that. But you depending on the length of the section, obviously a long section is, it's going to be a lot longer than maybe a short section, but so I don't really have a really sense the guide on the rate of increasing it, except that you want to be able to control it so you don't overshoot. Okay, so unfortunately, I don't really have a set rate. Now, in depressurization, I will tell you what I mostly concerned about in depressurization is controlling the discharge of the test medium. Okay, you want to do it at a rate that you're controlling the flow of, let's say you're using water, controlling that flow of water out. It's not going to take a lot, but you just don't want a geyser or a jet, okay, that could do damage or such or anything, and you may have to have environmental precautions also. You may be having to treat this water if you're testing an existing pipe and such. So the system that is going to handle this water may be what limits your depressurization. But to me, it's just it's kind of a site by site a way of doing it? Are you depressurizing it through a hose or anything, or you don't want it the hose to whip around, and such, and maybe injure folks? So I don't really think I can give you a set rate answer the question, except just give you some things to think about when you are pressurizing and depressurizing. Hopefully that answers the question.
No, I think that was very good. I think that was very good, Rob. Well, we have only a couple minutes left, everyone. There are still a number of questions that are kind of hanging in the balance here. What we can do is we will take note of the questions that were not answered, and we can I can get with Rob, after the webinar here over the next couple days, have Rob answer them, and we can get back with you. So again, everyone, there were still a number of outstanding questions we didn't get to that were either technical or even software related. What the capabilities, the uses, limitations to the Hydrotest PowerTool, look, at the end of the day, it can handle, different elevation profiling, combining sections or creating multiple sections of pipe straining together over, a given number of mileage of lengths. And of course, leveraging your asset data there to create a Hydrotest design and plan, of course, with a robust report as well. So in lieu of that, we will be having that discussion. You can see it with your own eyes 2 weeks from today on the 27th. The time will be the exact same, and everyone that attended the webinar today will be on that blast if you want to attend. If someone did not attend this and they want to join, forward it over to them and have them join, because we will just be forwarding or creating that for the people that joined this webinar. So again, thank you, everyone. If we missed your comments, we will definitely be following up with you. And for the ones that are interested in learning a little bit more about the software itself, we hope to see you in 2 weeks. Again, this is Joseph Ladner. We'll be signing off at the webinar here. Thank you, everyone, and hope you enjoyed it. Hope you found it to be beneficial. See you in 2 weeks.
Can I add one last thing?
Yes.
In case anybody's wondering, it was the surveyors. That's all.
There you go. Love it. Great way to end it.
All right. Thanks. All right.
Thanks, Robert.
Thank you, Rob. Thank you, everyone.
Right.
Have a good one.